Today we're going to talk about nuclear radioactive decay. So, we're just going to solve some practice problems in regarding that. We need to be familiar with these two equations. So, this is going to be the final amount of the substance. So, let me just write final amount for this one. So, this A sub 0 is going to be the initial amount of the substance. So, we all know that um, some certain elements they undergoes radioactive decay, and to calculate that we need to use this equation. So T is time and this K is going to be the rate of decay. Rate of decay, so that's going to be rate of constant. Rate decay of constant. It's much better. Just write it below this one and make the arrow much bigger. So that rate of decay constant can be calculated using this equation. This is equals to ln2 and this t sub 1 half is going to be the half-life. So half-life, so this is very common in nuclear chemistry and nuclear physics. So half-life is considered as it represents the time it takes for the half of the substance to be decayed. Miss a letter here, it should be half of a substance to decay. There you have it. So that's going to be the half-life. And let's solve some practice problems to calculate and use these equations for good. Iodine 131 has a half-life of 8 days. If there are 200 grams of sample, how much of iodine 131 will remain after 32 days? So this is very straightforward. We can just basically put in what we know here. So what we're going to calculate is the final amount of the substance after 32 days. So first, let's calculate the constant rate or the rate of the radioactive decay. So ln2 divided by 8, that's going to be 0.08664. So now what we can do here is plug it into our equation. So our final amount is going to be equal to 200 grams times E raised to the negative 0.08664 multiplied by 32. So that's the time it takes to find this. So the final amount after 32 days is going to be 12.5. I thought that was okay, so 12.5 grams. Sodium 24 has a half-life of 15 hours. If there are 800 grams of sodium 24 initially, how long will it take for 750 grams of sodium 24 to decay? So we are going to put what we know here, what was given to us. We have the half-life of 15 hours, we have the initial amount of 800 grams, and we're going to calculate how long will it take for it to reach the final amount of 750 grams. So first, let's calculate the rate of the constant. So that's going to be 0.04621. So now, we can plug it in here and solve for t. But before all of that, let's solve it by using algebra. So let me delete all of this and let's manipulate our equation. So let's write our rate of constant here. So it's going to be 0.04621. And now let's manipulate our equation. So what I can do here is divide both this by a sub 0. So we get Euler's number here, raised to the negative k and t. So now what we can do here is take the natural log of both sides. So we got a sub f divided by a sub 0. That's going to be equal to negative k times t. So we can just divide both sides by k and negative k. So we got this equation. So now let's calculate the time. Let's plug in what we know. This is our time. Okay, so the time it will take for the sodium 24 800 grams to take into 750 grams with the half-life of 15 hours. That is going to be this number. So let's use our calculator. This one. So we get negative 0.04621 on the denominator. So this is going to be 1.4 hours. The half-life of oxygen 15 is 2 minutes. What fraction of sample oxygen 15 will remain after 5 half-lives? So initially we have 100% of oxygen. So after 2 minutes, that 100%, we're just going to divide this by 2. So we only have 50% of oxygen 15. Another half-life, so it's going to be 25% of oxygen 15 will have left. Another half-life, this is going to be our third half-life. That's going to be 12.5% of oxygen 15 that will be having. Now we will undergo another half-life, so going to be our fourth half-life. So it's 6.25%. And another half-life, this is going to be the fifth half-life, so that's going to be 3.125%. So now what we can do here is divide this by 100. So we're going to divide this by 100. Actually, we did this in percentage, so let's multiply this by 100. So the fraction of 15 that will remain is 1 out of 32. 1 over 32. It takes 35 days for a 512 gram sample of element X to decay to a final amount of 4 grams. What is the half-life of element X? Okay, so what we can do here is write down what we know. We have time, what's 35 days. We have the initial amount, that's going to be 512. We have the final amount, that's going to be 4 grams. So it reduced ridiculously, have been reduced. So what we're going to do here is calculate the half-life. So first we need to calculate the rate of constant, the constant rate. So in order to do that, we need to manipulate our equation. So we're going to divide both sides by L sub 0 and take the natural log. So we have time over here. So we get K. So we're going to put our negative to the left side of the equation. So now let's put what we know. So we get 4 here, we got 512. And we're going to divide all by 35. So K is going to be 0.138629. Okay, I'm just going to put some numbers. Now we can use this equation, so the equation that we have earlier. So K is equals to ln2 divided by half-life. So now we can just cross multiply and divide both sides by the constant K. So now let's divide both sides. So the half-life of This element X is going to be 5 days.